I'm CEO at Misty West. I'm an engineering physicist by training, and I've been working in deep tech for 15, 20 years now. And today we have a panel to talk about some of the big pain points when you're bringing new technology to capital-intensive industries that tend to be very risk-averse. So I'll give some quick introductions for all of our panelists, and then we'll hop straight into it. The first person here is Vivian Hegde. Sorry, bear with me. He's a founding and managing partner at Zakua Ventures. They're an early stage venture capital firm investing mainly in construction tech. And he has been working in construction technology for over 2 decades, working at Hilti. Some of the people who invest in his fund are Volvo, for example. Next, we have Brendan Skiffington. He's a manager at Norcat, an innovation center in Sudbury, Ontario. They provide an operating mining environment to test new mining technology in a functioning mine. He's also head of Oven's Northern Regional Technology Development Group. And then next we have Vivek Bhagat. He's Senior Vice President of Engineering at Liminal Insights, where he leads development of EchoStat, an ultrasound inspection and machine learning analytics platform for battery development and supply chain. So they inspect battery cells as they're coming out of gigafactories and things like that. And then next is Bibrajit Halder. He's CEO and co-founder of Safe AI. They're a leader in autonomous trucking and heavy vehicles. He's been working in the industry since the DARPA Grand Challenge and has worked at Caterpillar, Ford, Apple, and Faraday Future before he founded Safe AI in 2017. And then the last person is Tori Shivanandan. Yay. And she's COO at Radiant, helping build the Earth's first mass-produced nuclear reactor. She makes sure everything is on track and that they can produce at scale as opposed to just make one-offs. And before that, she was a senior leader at McMaster-Carr, which anybody who's working in deep tech probably says a small prayer to every morning when they wake up. All right, great. So, yeah, I'll give a little bit of a preamble really quickly and then just hop straight into questions. So at Misty West, we've been working in deep tech for over a decade now. And I'd say there's been kind of a groundswell around deep tech generally. Maybe we're running out of good tech companies to invest in. I don't know what exactly it is. Maybe having SpaceX and Tesla exist and be profitable is part of what's helping that happen. But one thing we've noticed working in deep tech for so long is that, you may have heard the phrase crossing the chasm. The chasm in deep tech, especially in capital-intensive industries, is huge. There aren't really like early adopters almost. It's just like go straight to late adopter town. And we see a lot of companies struggle to jump that gap. So we wanted to run an event today to talk a bit about what are some of the lessons that experienced people like our panelists have seen people make use of, and basically go looking for a jetpack to get over that chasm, or maybe a rickety wood bridge or something. We'll see. Okay, so with that, I'm going to ask the first question here. Brendan, maybe we can start with you, and then I'll pass the mic and we can see where we get to. So I think you may have also heard the advice like move fast and break things. I guess that's something Mark Zuckerberg used to like to do until Facebook got big. And you may also hear the phrase, just ship it. In deep tech, especially when you're selling into, say, like mining or energy infrastructure or like a large factory, just ship it often isn't great advice, because once you get out there, you can't just release a software update or something. So one thing I've seen go well is the idea of go fast to go slow to go fast. So maybe Brandon, you can talk about some examples where you've seen that happen, and we'll see where we go from there.
Yeah, thank you. So,
I forgot to mention one thing. Troy needs to leave at 3:30 sharp to catch her flight. So.
Perfect. So, yeah, the whole go slow to go fast, it's definitely advantageous in deep tech, but honestly, it's probably essential. Like Mark mentioned, you can't go to a mining company with an idea, ask them, hey, let me use your mine. I'll spend a couple weeks, a couple of your personnel, test it out and prove to you that what I'm saying actually works. They get requests like this in the mining industry, especially hundreds of these requests a week. They don't have the time. If they're going to stop operations, that's a loss of hundreds of millions of dollars of profit. So you have to be able to go there with a proven technology, and that's where NORCAT comes in. We actually own and operate a fully operational mine. So we do the drilling, the blasting, the mucking, and we allow our startup clients to actually integrate their technology into our mine. So now, once they're able to validate that technology in our mine, we become their first referenceable customer. So now they can approach the Vales, the Glencores, the major mining companies, invite them to our mine, and be able to show that it's a proven technology that's easily adoptable into their operations with limited downtime. A great example, one of our companies called Testman. They created a loader that removes a worker from the face of the wall, which is the most dangerous part during the drilling and loading of the blasting material. They took years at our underground center, perfecting their technology, installing it on a bunch of different types of vehicles to make sure that it can work across multiple corporations. And then they've just continued to fine-tune it, and they were able to prove that it's ruggedized, it's reliable, it works over a course of multiple years in this harsh environment. And then it was a simply matter of inviting Glencore to come over, take a look, let their workers use the technology themselves, and within a few months of that initial meeting, they received a purchase order. So that's their second customer, major mining operation. Vale then caught wind of it, and they were able to show them the technology to them. And development took 5-6 years, but once they were able to prove that technology, they were able to get massive purchase orders from some of the world's biggest mining companies.
Maybe I could just add to what he said. At Zakua, we use a term called gentle disruption, right? When you talk about mining, construction, other legacy industries, you don't earn the right to just go and disrupt them, because they have processes which have been built up because of the level of risk involved, because the margins are small, because the cost of disruption is very high, their lives at risk, and so on and so forth. So you have to go and prove that you can add value without disrupting the existing workflows, and only once you earn their trust and you deploy the solution and shown value, do you earn the right to actually disrupt their workflows. So the concept of go fast and break things doesn't really work very well. It's more about learn their workflows really, really well, add value to what they're doing today, and then earn the right to reshape those workflows once you've shown that you can add values to the things as they stand today.
Bebrijit, I think I heard you say that there's a reason behind why you named your company Safe AI. Maybe you have something you want to add here as well?
Absolutely. So I think if you think about, first of all, before I go there, thank you for hosting this. I could not imagine somebody will be interested to talk about mining in San Francisco. Like, something must be wrong. Like, who talks about mining in San Francisco? But so thank you for that. I think Safe AI, if you look at it, is a technical term. I mean, these days, because of AI, nobody can talk about AI without the word Safe AI. So if you're using the AI for a safety critical application, you better make sure that AI is safe. What we use AI for, driving this 400-ton truck 40 miles an hour 24/7. You better make sure that AI that driving the truck must be safe. So I think that is the premise of our company, and we have a bunch of patents around that. But today, obviously, everybody's talking about Safe AI or AI safety. One thing just to take you from the industry point of view is that I think we adopt the Navy SEAL approach. The slow is smooth. Smooth is actually better, and that's fast. That's kind of approach of Navy SEAL. In our industry, that works the best.
I'll add one thought, because I really appreciated that point. So Radiant's building a micronuclear reactor. Go fast and break things is just not possible. Like, you should all be scared if that's the way we're approaching it. And I'm going to say that, and then I'm going to say we're going fast and breaking things, because I think as developers, we have a point as those pushing technology that we have to know the edge, and we have to find out what the margin is, and you have to go above that margin as you're building, and then you have to have done all of that before you deliver to the customer site, so that it is seamless and smooth when it gets there. But you have to understand and be very realistic about the challenges you're facing. I mean, what was it, 400 tons at 40 miles an hour? Like, you probably test larger and faster than that, because you have to have answered all those questions of the what ifs, and that's where the break things come. But that's so much further before we get to the bridge.
Awesome. Thank you for all your insight there. And Vivek, I have a question for you too here, which is, about finding that edge. Obviously, liminal insights, that's what you do, but for batteries. Can you talk a little bit about how the landscape is changing on that front, like how advances in sensor technology or in simulation or maybe in machine learning are changing how we find that edge?
Sure, thank you. So connecting with your prior questions, go fast is necessary for opportunity cost for our customers. So what our customers make EV batteries, and today with EV cars growth, everybody wants to come up with a technology where they can make EV batteries faster, cheaper, and safer. Now, to do that, to get in first in the market, sometimes they need to break few things. But some of you might have heard in past that there was a Chevy Bolt recall and fire. Because of that, GM and LG, they need to recall their cars, and it was like more than a couple of $1 billion loss to them. Similarly, recently, few months back, Ford stopped their EV manufacturing because of the fire. So in the battery world, going fast is critical. At the same time, having safety is also equally important. So in that regard, company like ours, where we develop unique technology with ultrasound, which is non-destructive, help battery manufacturer to find out these defects and these challenges in their battery, so that they can come up with a safer battery, and then they can help ramp up quickly in their manufacturing industry. So as a startup, new technology can help customer to come up with faster to their products, and that's how they can have a bigger opportunity in their marketplace. So as a startup, I think coming up with the technology and providing a unique solution to customer, that is very, very, very important for us. And that's how we enable our customer to run faster without breaking things.
Okay, so the next thing I was hoping to talk a bit about is the timelines. As we've kind of alluded to, Brendan, you mentioned a company spending 5 to 6 years in your mind just proving out their technology before they actually start signing purchase orders. That's a long time, especially with interest rates where they are right now. How can deep tech startups be default alive when they have to take that long to get to market? Like, who is going to underwrite the amount of capital needed to take this technology from a napkin sketch to commercialization if you're, say, building a micronuclear reactor? David, I was wondering if we could start with you, and maybe you could share some things.
Sure. It's very important to think about the capital stack, right? The kind of funders who are backing you. So you don't always want to go to a VC and take your first bit of funding if it's a deep tech project when you are at tier L1, right? You have to think about, okay, can I have access to grants? Can I have access to angel funding? Can I have access to infrastructure funding? Can I have access to venture funding, debt funding, and so on? So knowing your capital stack is very, very important, and matching that to your timelines is also very important. I would never talk to a VC until you are at least tier level 4, 5, and so on and so forth, right? So stage one, look at research grants that are possible so that you can get this up and running, whether it's universities, whether it's Department of Defense, whether it's government organization, and so on. Once it's a little bit further along, look at angel funding or friends and family funding to make sure you have prototypes. Again, I'm not talking about nuclear plants, which could be very different, but I'm talking about hardware prototypes in some cases, right? So go as further along as possible without trying to get access to venture funding. And then, thank you. And then you want to take risk capital. You want to take risk capital to experiment and push this further and develop something that is almost productizable, right? And finally, when you come to scale, you think about infrastructure funding. People who have deep pockets are not looking at 3, 4, 5-year time horizons, are looking at 10, 20, 30-year time horizons, evergreen funds. And this is especially useful if they're also potential customers to you. Because then you can look at offtake agreements which are tied in with investment that you're taking, and you are de-risked from a perspective of deploying it initially in the first few years as well.
Yeah, I think understanding the funding landscape is extremely important. In our province alone, like our government wants to get those critical minerals out of the ground better, faster, cheaper than any other country, any other region. And they're investing over $1 billion. And they're giving organizations like ourselves funding to be able to use the Underground Center completely free of charge for companies to go to their local college or university, use their R&D spaces completely free of charge. So you can get capital that you could use towards your company, but you can also get a ton of free resources and access to R&D sites to lower the cost as well. We've seen some of our clients take some pretty creative approaches in order to get to market quickly and cheaply. A lot of open innovation challenges. Major mining companies aren't doing internal R&D and technology development anymore, so they're actually just posting out what their main challenges are that they're looking to solve. And we had one company that had a similar product that could solve a challenge, and they applied, ended up being successful. So they got access to cash, the resources, the employees, data, everything that they needed to develop and modify their product. And within 6 months, they had a product in operation at a major mining company. Throughout that, though, they developed a deep relationship with them. And now the major mining company continues to go back to them as a service provider for a lot of the technology. So you have to get creative. You have to be able to slightly modify your existing product to fit the needs of your client. But that was one of the creative ways that they got in.
Yeah, I think from startup perspective, we definitely don't have many resources, and how do we enable our customer to adopt our technology? So in EV battery manufacturing, we know that our ultrasound technology can get value to many insertion point in the manufacturing to solve customers' problem. But at the same time, we don't have resources, and we have money to go to all the places where we can go. So as a startup, we have focused on the end of line quality for the EV battery cells. So helping the customer to focus on solving their critical problem, we have narrow focus on our resources to solve that problem first. So that way, we getting some wins in our belt with deploying our startup technology to a specific customer use cases, enabled us to start generating revenue and also having focused resources for our products. And at the same time, there are, if you have seen the last many years, there are so many new EV battery manufacturing plants are coming up, so much announcement going on. Government is giving this IRA incentive to companies. So we purposefully choose to whom do we want to work with, because sometimes if we try to work with many customers, then our resources will be spread thin and we will not able to demonstrate any success. So we work with the customer who are really see that their product is going to come to market in next, let's say 3 to 5 years, and we work with them to enable them to be successfully deploy their battery manufacturing plants. So focusing on our own core and where our strengths are, and making sure that we work with the right customer to drive our technology adoption is also critical, and that's how we try to constrain the resources what we have.
Yeah, just to maybe add on, so what we do, I mentioned we take the big truck, make it fully autonomous, and run it 24/7. So there is no lack of technology. It is deep tech as it must goes. But I think if you're a startup, and we are VC-funded startup, expectation is very high. The way to go from innovation to production, you need to speak the production language, right? When we go to customer, our customers are the top tier $100 billion mining companies across the globe. We don't say our AI is better. We are using this data, and we said, you spend $3.50 to mine 1 ton of material. You're going to use autonomy. I'm going to make it $2.80. And they come back to us. They're like, then all of a sudden they are there. They want to hear. Then even if we give $3 per ton, when we say $2.80, they are sold. I think right now we are deploying about, in one of the gold mine in Australia. We are going to go in Canada. So I think that's the difference. You need to be able to speak the actual dollar with the customer. And if you think your product is not there yet, not proven out that you can speak dollar, that means you shouldn't be in a startup yet. That's why Vivian was saying, go get the grant, go get whatnot, because by the time you take a VC money, they expect a revenue. So I think you gotta kind of draw the line, can I speak the dollar value language? And autonomy is easy. It's a very well proven out for our industry. We can really show, if you take autonomy, put it into a truck, your $3.50 per ton to move, we're gonna reduce it to $2.80. So I think that's the clear message, and we have other problem. And we were mentioning that they are slow. There is not a mining company we go and they don't ask me why we use your solution. You're like, do you have a distribution center? Can you actually do 100 truck today, right? So it's a very different discussion. So I would not say they are behind. And just one anecdote to that, autonomy, just for autonomy, Google started way after mining industry started. Mining industry started full autonomous back in 2006. Google actually took some of our people, I was there at Caterpillar, took some of our people from Caterpillar to start their autonomy. So I think that this industry is innovative when they have to be.
Okay, so I have a slightly different take. Yeah. So Radiant's first commercial units will be available in 2028. And so absolutely we have to be able to understand the economics of our reactor. We have to be able to make it relate. We're replacing 1 megawatt diesel generators, so we have to be able to talk that same language. But I think the way to actually think about it if you're far from revenue, I have a high risk profile. I left my job at an industrial supplier to help build a microreactor. And I have to recognize that not everyone who I talk to about my technology has that same risk profile. And not all types of capital, to go back to where some of the comments started, not all types of capital have the same risk profile either. But you have to be able to find the waypoints and the milestones that translate what you're doing to buying down that risk. At Radiant, we will have our first field test in 2026. There's the NRC, there's DOE authorization, all of these things which can build someone's risk profile. And I think that one of the things we've done well is we've tried to say, here's how we can show you and bring different folks along. And we have a duty to the general public too, because we're building reactors. I can't turn on a reactor tomorrow, but my team can turn on a helium loop and put it on YouTube and show everyone that it's safe and that it met the product bounds. I can't turn on a fueled reactor tomorrow, but our team can build a version with all commercial grade products and bring it to temperature and pressure in the parking lot this summer. And you can walk yourself there. And even our first field test won't be a commercial reactor. I can take a regulatory process and say, DOE authorization, what you need to know, it's 5 documents. These are the dates we're going to get there. And so it's about recognizing where the risk profile of who you're trying to engage with is and how you can show them you can deliver. you can build that trust, and you can say, I can buy down risk with this milestone, and then our team can deliver on that milestone, and then let's keep the conversation going.
Awesome. I'll ask you one question too, which is there anyone who would buy your helium loop as it is now? I mean, I'll expand no comment. Okay. Yeah. I mean, one thing, and maybe I'll throw something out there, and if any of you want to say something on it, you can. But one company I think of in this space, which many of you probably heard of, is a company called Hermeus, and they're trying to build hypersonic jet engines effectively. And so they're thinking creatively about not just like I would say like a beachhead market, but also like a beachhead application. So like instead of building a hypersonic jetliner as step one, which is already a pretty crazy project. Yeah, I mean, even if you're Boeing, sometimes you have problems, right? They're going to start with a test platform, I guess called Quarter Horse or something like that, and they're going to sell access to that test platform. So if you want to do, instead of buying access to like a hypersonic wind tunnel, you can buy access to their test platform, which will be way cheaper. So I guess my question to the panel is like, are you aware of any cases like that in your industry where a firm or a startup or somebody has been really creative about where they can sell what they've developed already, or like, are there earlier points to revenue if you get creative as a way to kind of, in addition to everything you were saying, Vivian, which I think is all critical. Anybody want to?
So I think this is important when you're doing deep tech, it is important to start in a very easy use case. And you can kind of see, right? If you look at the Waymos of the world, you can see they're running here. It's much harder problem. If you're running autonomy in mining, much easier. Even in mining, there are areas that are use case much easier. So we also do construction. So maybe I'll give you a kind of use case there. So we're also doing autonomy in construction, which is much harder than mining. What we are doing there, they run about 8-hour shift. We go at the back of the last 5 hour. So they run their 8 hour, we do 2 hour of the extra and take extra 3 hour. And we are actually matching their productivity of the day or overshooting that because we are giving them the last 5 hour. That's a very innovative way to get into their system, say that I'm not bothering your system, I'm not testing my system, but I'm using a very small portion of your thing, easier use case to get your technology in. I think that's the important when you do hard tech, find the easier use case, actually give some real ROI to the end user, then they will buy into it, not because you have some fancy PowerPoint, right? Again, going back to my words, you gotta show them dollar. And not by a presentation, but actually dollar. I think in our use case, we always do that. Easiest use case, and they grow from there.
Sure. So in EV battery, no customer would like to have a unsafe battery with defects. So it is impossible to ask them, okay, can you give me battery which has defect? So how do we prove our technology? So what we do, we start with building a batteries with synthetic defects. So we purposefully create problems in the battery and then try to inspect with those batteries with our tools and demonstrate to customer that how our technology is working and is going to help you. So today they have a certain technology to identify like electrical test and reject the battery, and we work with them to try to figure out why you are rejecting these batteries. So it is important that when we are coming with a new deep tech technology, proving that technology to our customer is very, very important, and how we can come up with innovative ideas to solve this problem by creating synthetic problems, working with them. We are engaged with some labs in the Europe where they have a process tools for the battery, and then we work with them to create this kind of a challenging batteries, and we inspect those, and then we give them answer, and that data we use with our customer. Because customer, they are so IP sensitive, we cannot share our different customers' data with each other. So that is how we try to solve this problem. Sorry.
I think someone mentioned it really early. I'm not sure which of the two of you it was, but the US government has a lot of grants, and a lot of the times that you're developing things, like there are parts of your solution which can be used in other industries, and you can go get a gain voucher, which is 500K, that's a real amount of money to go find out if your software works. And there's all of these, I'm sure you guys have done similar things where we live in an awesome place where that is available, and you can use that to buy down risk in creative ways. So.
Yeah, I could speak about our underground center itself. It's very costly to run a mine, and startups don't have a lot of money in order to use it for testing purposes. So we actually offer training for anybody that's looking to work underground. The major mining companies, again, Glencore, the Valets that are in our region, they will use us to train their current employees, and that helps covers the cost so that startups can then use the mine to do some testing. And then we have another one of our clients. They're looking to sell fully a product off the shelf that can go on any type of vehicle, and it would make it completely autonomous underground. Mining companies aren't there yet. They're probably a couple of years from being able to completely convert their fleet. So they're actually using their technology from phase 2 that they used to help train their model to go completely autonomous for collision avoidance purposes. So the mining companies are ready to implement that. That way now they can again build that relationship with them, and then when the mines are ready, they can adopt a completely, fully autonomous fleet.
Just to kind of summarize some of what they said, right? I think there are 3 ways in which you can do it. The first is obviously leveraging grants or other supports which exist, which a couple of people mentioned here. The second is taking bite-sized approach. For example, we have a company called FlexNode, which makes sustainable microdata centers. They're saying, okay, can we install racks instead of having the fully built-out data center itself being deployed? That makes sure that the problem is much easier to solve. So that's the second approach you can take. And the third approach is byproducts. So we know a startup who's trying to build a nuclear fusion reactor, but the byproduct is flux, which is created. And this flux can be used to treat cancer and other medical treatments and stuff. So they're saying that could be a first use case before we actually get to building the fusion reactor. So it's about knowing the product that you're building and what elements exist, and then you can leverage any of these different types of support systems which exist. But you have to be creative about it.
Thank you. Great insights there. So for the next question, I wanted to talk a little bit more about selling to these large capital-intensive industries, which often have large companies in them that you're trying to sell to. I think that can be a very different environment from a move-fast startup environment. Things like corporate restructuring can happen. Right now in mining, a lot of the mining companies are busy divesting themselves of their coal and iron businesses so that they can sell those off to private equity so they disappear if anyone's looking for carbon. So that's a problem, right? Like if you're working with an innovation group there and they're going through a whole reorg, like it's totally possible you could lose the stakeholder you have who is backing your project or who was really enthusiastic about your pilot, and that can totally shut things down. And then the other problem you'll run into too is, there are a lot of stakeholders at these large companies. So one of the questions I wanted to ask then is like, how do you deal with challenges like that? How do you engage a large enough audience at these large companies to make sure that you don't get disrupted? I don't know.
I can start maybe just to give you who our customers are. Like one of our customers is Thies in Australia. So usually all of our customers are mega mining company or mega construction company. Minimum like 80 to 100 billion plus, right? These are the size of those company. I think for us, even for any deep tech, the more future vision company you are doing a vision sell. So you can understand, am I doing a vision sell or am I doing a product sell? If you're doing a vision sell, you gotta go all the way up to the CEO. How do you go? That's a different point. But like we talked about, we sell it to Vale, Codelco, the Rio Tintos of the world, Thies of the world, Suncors of the world. You gotta get to the CEO because you are doing the vision sell. If it is a product sell, you can go to the mid manager. You gotta tell to the CEO, if you do this, this is gonna transform the industry the way you do. Any country you enter, we are in Japan, our customer is Obayashi. They are the largest construction company in Japan. Any country we enter, we go to the top, think about the leader of that country, and we do the vision sell. So I think that's the difference, right? If you're doing the technology. And once you get the higher up, the CEO level, CTO level, say, yep, I like the vision. This is where I want to take the company. This is where I want to take the country. Then you gotta really get down to the operation guy. The operation person has to believe and let you do that. This is where the dollar comes in the picture. So you get the CEO and operation. This is the two main stakeholder. And innovation person is just that's your basically the wrong one to go. That's an easier one to go, but that's a wrong one to go because you're going to circle that all your life of startup if you don't get out of that, right? So for your real product is the CEO and the operation guy who is actually running the mine, who care about the dollars and cents. You got to get these two person over the finish line for at least for our use cases.
Yeah, I think it's a really great question, and there is no easy answer. But when we have a new technology, we have to prove it first. So for us, working with the customer means all our customers are large EV battery manufacturers, and now in their organization, who has this critical challenge? So there is a quality guys, they are looking for the defects in the battery, trying to minimize that. There's a process guys, they want to optimize their process so that they can produce the right types of battery. And there is, of course, operation guy who want to just run the factories and they want to making sure that all the tools which we develop, bring in remain up and or it's reliable and remain up and running all the time. So whom do we target first? So first, what we try to do is who has the most challenging problem and whose job is at line when this fails. So we work with those customers to help them to be successful in their own organization, and we make sure that our technology, they see the value of it. As soon as they see the value of our technology, we enable them to sell our own technology and products within their own organization, and that's how they market us with showing the value of our technology to their other team members. And then we start putting so the way we start with a eval tools in a customer factory, and then we work with them and demonstrate our technology, and then once they have data and on their own products, now they go to the manufacturing line and operation lines and then say, okay, now we want to deploy this product in operation. So we start with the R&D labs with customer and then work through that to the deployment to the operation teams, and then it goes to that level. I think as Mark mentioned that there are three folks like CEO, operations, and engineering, all are important for our industry. All three are important for our industry, and we have to work with all of them at some point.
Yeah, lots of stakeholders. Hey, Richie, I wanted to double click on what you were saying. How do you get to the CEO if you're a small startup?
Yeah, so I think this was when we started the company, we were about 5 people, and a lot of the VCs, they're saying, go up in the smaller mining company, smaller construction company, right? It's easier for you. Don't do the bigger truck, because CAT and Komatsu of the world doing the bigger truck. And I was like, no, this is where the money is. This is where the money is. So to your, because you can, there is a reason why CAT Komatsu goes to the big mining companies sell for the bigger truck. There is a reason they don't go to the moms and pops of the shop, because that's not where the money is. To your question, how do you get to the CEO? I mean, we come from that industry. We've been in the mining industry a long time. So when we kind of, let's say we approach Vale or approach Suncode, right? We inherently have the industry, I would say, bias, because we come from that world. So we can get to the Suncode, not the CEO, but the next line on the CEO. Suncode CEO is too big. So I think for us, the way it is, it's really through our contact, we go to the all the way top. But I think more important is that you need to know that that's what you want to do. If you're trying to get to the VP, you're trying to get to the innovation guy, you're going to reach there. When you talk to the Thies, it's like, I want to talk to the CEO of the Thies. Because this is, I cannot sell this thing to a mid-manager who is just running to mine. And they need to make a profit today. They're like, why autonomy? I'm not going to make profit. So I think through the connection, if you will, and now that we build enough, now that Thies, we talk to the Thies CEO, so now Suncode also say, okay, I also want to talk to you. Why is Thies CEO talking to you? Then we slowly open the door one by one. Yeah, if anybody wants any mining, I know this is a mining range. I visited over 25 mining last 6 months. So I can make connection to the mining industry.
There you go. If you're building a new mining technology, come talk to you.
Any day.
Tori, do you have anything you want to add, or don't you read the slide?
No. If you have to, right? Like, I think someone when I first started at Radiant told me like the age-old business school sales advice, which actually might be kind of controversial in SF, but don't sell filet mignon to vegans. And I'm in an industry where like there are people who are already pro-nuclear and there are people who are not pro-nuclear. And I think your point early of like knowing who you are, like for an organization, a big organization in the oil and gas industry or in mining to come out and say, we're gonna back nuclear. Microsoft, Google, when they came out and they said they wanted 50 megawatts by 2030, it's a huge organizational change, and you have to the vision cell. I love that, right? You're not gonna get there just by doing the small work, but you have to also do that too, because especially if you're selling a reactor. Is that better? Okay. If you're selling a reactor, and we actually do have a mining customer, Idaho Strategic Resources, out of Coeur d'Alene, Idaho, and when we met them, the team understands how a micronuclear reactor can transform what they're working on. We also spent the day in the mine with the team and understood that the folks doing the hard work, pulling the gold out of the ground, also were comfortable with nuclear. And that was really important because they're the ones who are going to drive by the reactor every day. And so they have to feel comfortable with it. But I think you have to just be really honest as an organization. Are you doing a product sell or are you doing a vision sell? And you can't sell filet mignon to vegans.
All I would say is don't have preconceived notions. We have a very early startup that we funded, and they wanted to reach out to CEOs of like $20 billion companies, and he just wrote them an email and reached out to them on LinkedIn, and he actually has meetings with 3 CEOs in the last month, right? And this is a startup which has no revenue, very little, just an MVP of a product. So there's no right answer. Sometimes things just work. You just have to be tenacious and reach out to them. Obviously, advisor network definitely helps. Knowing the industry helps. Selling your vision helps. So you need to understand the pain points deeply enough, because if you're solving a true pain point for someone, then they will give you time, right? But you need to articulate it well enough, and you need to be brave. That you just need to go for it sometimes, and things happen.
Awesome. Just checking time. I think we have. I'll ask one more point about this too. Or actually, maybe we can get to questions a little earlier. Okay, so last question then. I wanted to just point out that in these industries and in deep tech generally, regulation often plays a large role. That's obviously the case with nuclear. But I think it's also very much the case with mining and infrastructure generally. I think in mining, for example, it can actually take even longer to commission a mine than it takes to commission a new nuclear power plant. Like, I think the nuclear power plant numbers are somewhere between like 6 and 10 years, depending on where you are. And I think if you're, it depends where you are in Canada, but like I think it can be 10 to 15 years, though that is changing, or there's some efforts going on there. So I guess the question I was going to ask is, what can be done to work around these constraints? Is it even possible to, shift how we think about regulatory, how we think about really like the precautionary principle, and like, have we taken that too far? Like, are we also thinking about the benefit, not just the risk? So I think maybe, Brendan, do you want to start us off, or?
Yeah, so in our province, the government actually appointed a new minister of red tape reduction, so that helps out a lot. But on that, it's oftentimes a lot of the politicians, the regulatory bodies, you just have to be transparent with them and talk to them, tell them what they don't know, all right? There's a lot of complexities with the hardware, emerging technologies. They may just not be aware of, fully understand what you're doing. So being able to just have those conversations, make them aware, it helps them do their job, and they also want to remove the red tape and the regulations because they want to be able to grow their economy as well. So I think having a good relationship with your government, your local MPs, MPPs, or senators is extremely important to get past those regulations.
So I think in our industry, like any other industry, regulation does slow you down, but it's a good for us. I mean, what we started saying that, right? Slow is good in our industry, but in our industry, regulator also works as an accelerator. And I'll give you one example. So we are doing two things, one in Canada, one in Japan. So we are deploying autonomous construction in Japan, but Japan has no history doing autonomous construction. So now we are actually also going into the government through our customer to set up the regulation strategy for them. So basically government saying that I don't have any way to regulate this autonomous construction for the Japan, I'm going to start doing that. Another thing we're doing in Canada is that the reason the width of the lane of a mine, haul road, is a certain way because human drives that in that haul road. We are actually going to the regulator saying that now that you don't have a human driving in the haul road, you can squeeze the width of the lane, and anybody who know mining industry knows if you can squeeze the width of the lane of a haul road, that's a multi-billion dollar. Because that's where under this haul road is where the mining materials are. So if you can reduce the width. So we are having the discussion with the Canadian kind of government regulation body. So Japan, what is happening, because now government getting involved, they are setting up the regulation. They are saying all of a sudden, everybody say, oh, that means it is coming in Japan. I should be doing it. So basically think about, we have our, what I call lighthouse customer, Obayashi, took the first step, but now that number 2, number 3, number 4 saw the government is working to set up a regulation body. And number 2, number 3, number 4 is getting interesting. So you can see how regulation is actually accelerating the whole industry. That everybody is looking at the government says that if government is setting this rule up, there must be something in it. So I think for us it is actually an accelerator if you can use it properly. Obviously it's going to slow you down a little bit, but it can use it. We're getting better at it.
We're gonna have to yell a bit.
That's a great point that might like cut out on you. I actually, when you were making that point, I actually think that the NRC has done a lot for nuclear that they don't get credit for. And we're right now working mostly with DOE for DOE authorization, but we are in an NRC pre-application. The NRC has taken a lot of bad press recently on being what's slowing down the development of new nuclear reactors. But I don't see a story where there were reactor designs that were mature, safe, well-tested, customers waiting at the end of those to receive the output and actually use the power with an application put in front of the NRC, and the NRC said no. And so they took a lot of heat. Recently, they're still taking a lot of heat, but they're serving a role that we Radiant want them to serve. Now, they're also operating with rules that were written before most modern software and technology existed. And so they're given a hard hand to play with. And I think in all of our interactions, we know the rules need to change. We know that the rules need to help things become faster. We also know we're not going to do that before we turn on our first reactor, and we're not going to do it before we sell reactors to customers. And so it's about knowing what it is they're looking for, why it is they exist, what the intent is, and where you are, and how you can bridge that gap and bridge that story. And also know they're a really big part of the story. Like you're saying, like they can also, most regulators have PR budgets. Most regulators have comms teams. Like they're out there to also help tell the story. They're on your side as a technology developer. most people who work at the NRC went to the NRC because they want nuclear energy to exist and be abundant, and they just haven't seen it happen yet in the US, and so they are excited to work with new developers. They're excited to work with old developers. I think they take a lot of heat, and it's just, you have to be really honest the whole way through the process on both sides, and recognize like the NRC is great. We need them. I'm sure others might not feel that until you've had regulatory successes, and we've had some, but not our big wins yet. But they're your biggest promoters also.
I tend to agree, actually. Regulatory tailwinds actually exist today. A lot of things which have happened today, for example, Europe is ahead in sustainability because of the regulatory climate that they have. A lot of heat pumps startups would not exist without the regulatory backing that they have. With the infrastructure bill, there's been so much more funding in a lot of these initiatives that has actually pushed innovation forward. That said, if you really want to influence the regulators, then you need to build a coalition. People need to come together. It's not going to be one startup or one company which is going to be pushing this. You need to have everybody working together, saying, okay, these are the 2 or 3 things that need to be resolved, and can someone help us resolve those, right? But in general, last few years, I've seen it more as a tailwind than anything else, whether it comes to safety, whether it comes to climate, infrastructure, all of this. I think there's been a lot of positive news on that front.
Okay, this is good news. Anything on that?
So I'm not in the industry where, or at least we are not making products which require government approvals or regulatory. At the same time, when we ship our product to our customers, they have to follow all the standards. So what we need to do is that we need to make sure, we need to work with some of our customers in Europe, they need a CE compliance systems. Some of the customers in Detroit, they have unions, and their unions have certain rules. Without that, unless our product complies with those rules, they will not accept our product in their factory. So what we need to do as a startup, we don't have resources to work with all these different standards. So we work with somebody outside partner who can help us to understand what enhancement we need to make in our product to support this regular compliance, safety compliance, because our core is ultrasound technology, machine learning. We don't know much about this, all the regulatory standards. So we work with partners to help us to understand what it is and how can we modify our product to make it deployable in Europe or in factories in the US. And that's how we work with it. We don't influence government or politics or like.
Maybe just because we have been so nice to the regulator. One area they are doing crappy job is the AI regulation. They have no clue what they are doing. They're coming up with the AI regulation. Just because you are so nice to regulator, I want to throw that out.
This is your chance for regulatory capture. Get in there. Okay, that was all the questions. So thank you so much to all the panelists. And Victoria probably needs to run. And we were going to do maybe, how long was it?
3 to 5 questions.
Okay, yeah. So questions from the audience, if that's okay.
I just want to say thank you to everyone, and thank you very much for putting this on. This is like an awesome stage group, and I love people who want to do big, hard, dirty things. So.
Yeah, thank you so much for coming in.
And we'll be talking about in case you have questions about hypersonics as well.
Okay, cool. Yeah.
Go fast and break things. It's a runner up chair.
So, any questions from the audience then? Just throw your hands up and I'll try to get to you.
Yeah, so I was in case of the manufacturing world and went to software for the go fast break thing, and it broke my brain when I initially saw it. I was like, how could you ship things that aren't working, coming from critical oil and gas applications? But on the software world where things are kind of merging together, how do you guys hybridize that when you're hiring new talent? How do you guys kind of change those habits of where you're doing those tests and not necessarily still shipping quickly, but putting in those tests so things are kind of done in a way that they keep the quality standards you would for like manufacturing.
So I think just to repeat it, the question was, how do you still ship quickly or have some velocity, which I think was in your slides as well, Mark, but still have testing and things like that to make sure that you're safe and that you're dealing with risk appropriately. Is that correct?
Yeah.
Yeah. Anybody on this?
Yeah, I'll say with hypersonics, you're bringing, the biggest concern we had was human beings underground. There's this incompatibility of doing something completely brand new. Tori had the same issue, right? Bringing a nuclear reactor, we're bringing a hypersonic machine, and you just have to bring a new thought process. It's robotic, it's autonomous, but the big companies made us get ATF licensing, alcohol, tobacco, and firearms, who certify explosives. They made us go do that. They made us do export. All these things, we didn't fit actually in those, we weren't a square peg for a round hole, but we found something that gave them some confidence that we went through some regulatory process. But it's always in the proof. Bring a product to market as fast as you can in a test environment. I think you're a lot better off.
I actually have an answer that I can throw out that we use at Misty West, which is a process called rapid learning cycles. And the idea is basically at the start of a project, you want to understand like where the uncertainty in the project is. There are going to be unknown unknowns, and you're going to have to eat those on some level. But to the extent that you can, like figure out where the risk is in your project, and then try to burn down that risk in like a very specific way. Like you want to identify where the biggest risks are first, and then like try to get lessons and learnings on those as fast as possible before doing things that are more like execution challenges. And that whole thing kind of leads into, once you start to scale up and commercialize, it's going slow to go fast, basically. You've done the learning earlier, so it looks like things aren't happening, but instead what you're actually doing is you're testing, say testing battery packs earlier, as opposed to finding out from customers once you've shipped them that things are free.
So I know there was this whole point around choosing your customer. And so if you're like privileged enough to have multiple people interested with limited resources to execute, what are the factors you care about when choosing a customer? Is it like, can they put a working capital, how fast should they move? Like, what do you kind of think about? And how do you actually evaluate it, right? Do you talk to people at those teams? Do you do like good reviews? Like, how do you kind of think about getting the right customer?
I can maybe simple. It's pretty simple for startup, right? Like obviously doing such a deep take, you're going to start with some sort of proof of concept and then production. He said simple equation is how much time you have to spend on them versus the first dollar that you use. So if it takes longer time it takes to talk to them versus the dollar comes, like that's your thing. Am I talking to them for 3 months before they give us the POC, or just talking to 1 month before they give us the POC? So it's really when the dollar comes and how much talking and how much effort you're putting there. Whoever is the top of the list, you go with that. Like I can give you a lot of examples, but it's a very simple for startups. We are looking for the dollar. Unless your dollar comes, that means you don't have time to waste. That makes sense.
I have a slightly different take. I think it depends on your stage of evolution. If your product is ready, then I fully agree with what Vibhu just said. But if your product is early, you want to talk to people who will give you the most feedback. Because you're designing your product, and you want to make sure the product is the best product when it's out there, right? And you can't do that without people actually understanding it, pointing out the flaws, helping you design a better product, and so on and so forth. So this person has to have the installations, has to have the understanding of the workflows, and it needs to be willing to put in the time to give you feedback on your product, right? And you want to test for that, that this kind of customer will spend that time.
If I may add, that in our use case, there are 2 battery manufacturers. One is very established, they are producing batteries for the last 7 years, and one is very brand new, and they are struggling with the problems. We would choose the one, even the smaller customer, because we can have that customer faster to solve their problems, and we can be successful deploying our technology versus working with somebody who's already established and they already know
and it will be very difficult to solve that problem. So depending on the where your product can get the most value, which customer would be the right customer in my opinion.
Oh, sorry. You had your hand up first. Oh, last time, and then.
So I have a question on how to track the regulatory aspect for a new product category. Probably that kind of product does not exist in the whole new product category. For example, we are making smell cycles. So there's a living thing and there's the products. How do you crack, because no nation in the world as of right now has any regulatory aspects for living machines. So how do you think that can be cracked?
The question was, how do you deal with regulatory for an entirely new product category?
Yes.
I mean, that's the AI question, right?
Yeah.
A little bit, but yeah, I mean, I think you wait for the European Union to regulate it.
That's right. They can tax it, they can regulate it.
The way you want to look at it is the way you want to look at it, safety of your product. So you don't want to be in a situation where your product are unsafe so you want to have those checks and balances where not to, because government is regulating or for your own company's safety, you want to make sure that those things are taken care. Now, as a new product category, government may eventually put some regulation, but for now, as a startup, at least you want to make sure that safety of your product is robust and that doesn't impact human or personal or whatnot, or material or whatever, right?
Yeah, you can still get sued, I guess.
Yeah.
Get product liability.
Yeah.
That's right.
But like we talked already about financing and finding the funds. I'd like to get back to that. I mean, a lot of this is a long cycle, but also it's equipment, so it's expensive. It's a lot of capex. Venture capital typically doesn't like a lot of capex and around financing. Grants often also prefer to fund grad students, postdocs, personnel. In established industries, okay, airplanes, you're an airline, you lease your airplanes. I'm sure mining companies probably lease a large portion of their trucks. Big equipment, even printing presses, you lease that. But if you build something new, right, if I lease a truck, I know, okay, if the truck's the collateral. But if you build something new and it's a prototype and it consists of lots of parts, banks are a lot more reluctant to do that. Do you have any experience with equipment loans, equipment leases, financing to get to that point, or any?
Usually the first product, you need risk capital. Banks won't fund your first prototype, and that's where you want to grow the research, the concept itself, through grants or something else. Usually VC money is what you want for the first prototype that you build, and then banks will come and follow on after that, right? But depends on how expensive your first prototype is. If your first prototype is $5 million, it's not a problem. If it's $20 million, you can probably still do it. If it's $500 million, then it's a problem, right? You want to know who you're solving this problem for, and then it could unlock some capital sources for you. For example, if the European Union is trying to solve some problems with respect to green concrete and green cement and so on and so forth, there will be infrastructure players willing to back such bets, right? If you're trying to solve nuclear, there will be players willing to back such bets. Same with space and so on and so forth. So you want to identify who you are aligned with and find those funding sources who will back in for strategic reasons outside of just financial reasons as well. There used to be a bank called SVB, which used to provide working capital.
Oh no.
Unfortunately, not much help.
I swear there's someone here from SPP.
What we found, if you can find a chunk of your machine that is off the shelf, like for us, air compressors, they're actually one of the largest expenses. We can actually lease or capital very low cost loans of these relatively expensive pieces of equipment. We don't have to finance them ourselves. So depends on your piece of gear, but that's what we do.
I think just to maybe for us, like our equipment cost anywhere from $500,000 to all the way to 10 million, right? You know, I think that what we do, we try to, our first one, we go to customer. So basically, at the very beginning, we beg and borrow and whatnot. So our first customer gave us 3 of those $5 million trucks. You could not have gotten from the bank. You could not have gotten from the. If I got gone to meeting for the, he's like, what are you wasting my money for a $5 million truck? So I think first was the customer. Then what we have done, then we went to the bank. Is once you have a kind of initial PO, we have a big big purchase order. Now you can go to the bank. Then bank know how to give you loan for anywhere from $5 to $20 million going for a hardware purchase. Very well structured. So I think first I would go to customer and they probably sometime can give you the initial.
Oh, we have a microphone for probably the last 1 or 2 questions. 2 more, yeah.
Anyone else with a question? Actually, here, you're so close.
Based on what I heard from your discussion, unit economics is the most critical component. So I'm curious to understand from the incumbents, what are the pushbacks that will de-risk that unit economics? You talked about margins, you talked about like different aspects of CapEx amounts, but like beyond that, are there other risk factors that you need to reduce for them to be able to accept a critical unit economic?
Large corporates don't like disruption in their operations, right? So even if you come with a solution which is good looking, they would want to know that this can be replicated. As Bibrijit said, right? They wanted 100 trucks to be deployed. If one truck is giving them 20% more efficient, but they have to change the process for that, the cost of deploying such a solution is higher than the benefit that they're trying to get. So they want you to think through all aspects of the operation. How's the deployment going to happen? What's your service support? What's your spare part availability when you're deploying this? How do they have to change their systems and processes in terms of deploying this technology? What is the reliability of this technology when it's being deployed? So all of these factors are things that you want to consider, and that's why you start with pilots, right? You start deploying in one location, you prove out the concept, and once it works, and they understand processes required to make it work, they start expanding into other regions, and that's something to keep in mind, even when your unit economics is starting to work.
Okay, so when I started with Shell, they were the game changers, funded us, and when we brought a technology to them, this extremely fast drilling, we call it hyper drill, they needed to see a 5 to 10x improvement because they knew they were going to deduct until they got it. And they said, by the time we're done with you, if you're 3x better, then we've got a way we can talk to the C-suite to explain to them why this is so great. So you better go after something where it actually moves the needle. When I said you got to sell the C-suite, you got to sell the engineers, and you got to sell the operations, because all three have to agree that this is going to move the needle and easy to adopt and all that stuff. And it's hard. But yeah.
Yeah, I agree with Mark. I think for our industry, EV battery manufacturing has been going for many years. So when we come as a new technology, how would customer value us? So we look at it, who is our next best alternative? That they are using, let's say, CT scanner today to do defect detection, and how, if they adopt our technology, what is the saving they are going to do? How fast they are going to scan their batteries with our technology and see the same value? And also our product cost would be, what is the ROI, cost of ownership they are going to see with our product, right? So looking at all these equations, then we can work with our customer to their unit economy and see, okay, investing in our technology would help them to save money and also get the better results.
I think we have time for one last question.
In the early days, I guess you mentioned the project learning cycle, and I imagine there's a lot of, when you're in that kind of execution stage where you've de-risked a few different ideas, and you're not sure what's going to pan out, I guess how do you parallelize some of those early experiments, especially when it might be a lot of different types of expertise? And I guess how does that kind of maybe also involve grants? Like, are you able to do multiple grants? Are you collaborating with different universities on some of these different ideas? So yeah, I guess how do you kind of plan out maybe that first spread of experiments? Or where does it get complicated?
Let me try and repeat the question. So the question is, how do you parallelize the development to, say, move as fast as possible, make use of as many grants as possible, things like that?
Okay, so I think that new technology, financing, and development, it's a bit of a drunkard's walk, because you have this big idea, and then you've got to go talk to this group and figure it out. What we did is we went back and said, I showed something from the 1970s. There's a ton of research. Now you got, Chat GPT who will help you, but it's a bunch of research figuring out what's been tried. It's better to go see what someone else did and just research the heck out of it, and then put up your wickets to go after this, and this market. But yes, if you can find somebody else's pain points, proof points, research.
I would say you don't always have to parallelize. Focus is very, very important. If you're trying to solve 10 problems at once, you won't solve any of them effectively, right? But there's a balance. As a startup, you can't just focus on one thing and leave everything to take its own time. So prioritization in terms of what will take you to customer value the fastest. That's the lens I would take in terms of saying, okay, this is the most important thing to solve now. Maybe it's not UI. Maybe it's just the product behind it. Maybe it's workflows. Maybe it's integrations, something else. So understanding what is bringing the most value is important, and that's how you would stack the different solutions. So you will have a graph where you say it's value and effort. Anything that's low effort, you want to do it immediately. Anything that's high value, you also want to do it sooner rather than faster.
I would plus one that and just say, like, I think the most common mistake we see is like mistakes at the start where companies don't properly understand where the risk in their development is, and then they don't prioritize the right things, and they go off and develop elements of their product that were probably going to work no matter what, but are very expensive to develop. And so that, like, you're not really adding value to your company when you do that. You're not de-risking things and proving like, hey, we're going to change the world. So you need to, yeah, and again, you don't necessarily have to parallelize. You can go in serial, and I think it just kind of depends on a bunch of different factors at that point, like, how are you funded? How much money do you have? How many problems can you tackle? What do you plan? How are you going to hire? What does your product roadmap look like? All those things. And on the grant side, I can kind of work Canadian, so I can talk about the Canadian grant side. There's tons of grants you can get access to, and usually they actually try to convince you to take multiple grants. They want you to match up. In the US, I guess, I don't know the situation quite as well. There's more like DARPA funding, and can you get funding through the Inflation Reduction Act directly, or is it like you basically have to be TSMC or something, building a new? Okay.
So some green banks and stuff, they actually provide you. So there are green banks in different parts of the country which actually funnel some of this funding. So you need to know how this funding is allocated, and it goes through different sources. And understanding the regulations itself is sometimes a pain, but it's useful to know where all you can tap into these sources.
So there is a funding from California Energy Commission also for the clean tech energies. So we have worked with them to get the funding. I think one of the way we have tried, our technology came from the university, and then our founders from the same university. Once you have some prototype, going to some conference and trade shows for the industry, talking to people that how value they see, and then based on that, it gives some confirmation that this technology makes sense. And that's how they started with this company, and then funding, got government funding, and then one thing led to another, and then the company was kicked off. Yeah.
and look at regions which are friendly. For example, NYSERDA has grants. The District of Washington has a lot of grants. California obviously has grants. So look at all of this. Look at national labs. Oak Ridge National Labs usually has grants for people who are working there. Berkeley Lawrence National Labs has some funding that comes out of it. Department of Energy, NASA, all of these have grants and funding which comes through. So just look through these sources and you can tap into some of those.
Almost sounds like a startup idea. Figure out where all the grants are and tell people. All right, well, thank you everyone for, what's that? I'm sure there are, yeah, I actually know of one. Okay, well, thank you everyone, and thank you so much to all of our panelists.